Before moving on to floating point types, let me focus on one very important topic, that is if you are assigning a long variable to a value, say 10 billion, 2 3 4 5 6 7 8 9 10, then the normal things won't work fine. You will get an error message, that is the literal 10 billion of type int is out of range. Now what's happening here is this value is treated as an int and then it is converted to long. So we don't want that to happen. So whenever you are using any variables that have type long, float or double, you must end them with a string literal. In the case of long, that would be L, and in case of float, that will be either small f or capital F, and in case of double, that will be small d or capital D, and here you can either use small l or capital L. So this is one very important thing that you must note, and you must end any long assignment, float assignment or double assignment with its corresponding string literal. Now moving on to the floating point types, we use floating point data types when our mathematical task involves decimal numbers. It may be when we are finding out square root or finding area or volume. So we have two floating point data types. One is float and the other is double. Float is useful when the data you are working with requires less precision. It may be when you are working with data representing currency values, because at that time our decimal places are not that huge. To declare a float variable, we use the keyword float and then the variable name, suppose x, and we can assign it to a value. Let's say in this case x equals 6.6, and then don't forget to end it with the string literal, either small f or the capital one. This is all about float, and let's move on to double. Double is denoted by the keyword double when you are declaring it. So let's make a program to calculate a volume of a cylinder using double values. So let's comment what our program's gonna be. It is finding volume of a cylinder. Now let's declare all the variables that we are going to use. One would be pi, the other one radius, and finally the height. Now let's assign them to their values. Pi will be 22 divided by 7, and when you are using mathematical expressions like this, you don't need to end this value with the string literal, but when you are using constants, then in that case you will need to end the value with string literal. And finally let's assign height to be 7. Now volume would be pi r times r and h. So let's print the volume. The volume is volume, and we run the program to get the volume. So this is all about double, and we are finished with floating point data types. Now we'll move on to characters. Now characters in Java are those data types that represent a single value, and Java uses Unicode to represent characters. Unicode is something that defines a fully international character set that can represent any characters found in many human languages. Uh, Example of a character data type is car. We use char keyword um, to define any character data type, and a variable name, and a single inverted comma are used to denote characters, and in there we place a single character, let's say a, and if we print that variable we must get a, and if you use multiple characters inside the single quotes, then we will get an error, and in this case you can see Eclipse also pointed out. So, and there is one more way of using characters, and that is by using the Unicode uh, Unicode numbers, and let's use the Unicode of a, that is 65, and when we print this we will again get a, and this time we used the Unicode or the ASCII value of a, that is 65. So we now have a final thing left in this character data type. Even though cars are not integers, in many cases we can operate them as if they were integers. For example, if this is a, and if you write plus plus x, that is the way of adding one, incrementing a variable by one. In that case we are increasing the value of x by 1. This is mainly used for integers, and even though cars are not integers, this will work just fine. So when we print this we must get b. So, and if you were to add this by 4, then you do x plus equals any value, let's say 4, then we should get e. So you can see we have a lot of power while manipulating with cars. So now we are done with the character data type. Now the final data type that we are left with is Boolean, and Boolean is used for logical values, and it holds only two possible values, that is either true or false. Let's see one example. Suppose we have 5 greater than 4, and let's interpret this in this way. Is 5 greater than 4? Well, it is. So this gives us a true value since 5 is greater than 4. So if we keep a Boolean variable to represent this, it would be Boolean b equals 5 greater than 4. Then this b must hold a true value. So when we print b, we will get true. Now if this was to be 5 less than 4, then it would be false, as you can see here. So we will cover Boolean data types more when we will be working with conditional statements like if or else, but for now just keep in mind that they exist and they are really important while we branch our code. So with that said, we have finished data types and variables, and there's still a last thing to do, that is about the string literals, which we had discussed earlier, when to keep them in double, long or short values. Suppose you encounter a statement that says long d equals times this, you can see here this whole value has exceeded the range of int, but unlike before we don't need to write the string literal l here, because when this expression is evaluated, it will be automatically converted to long. But if any of these two numbers, for example the last one, exceeds the range of int, then we need to keep the literal l like before, because in this case it will be treated as int, but since it has exceeded the range of int, we will get an error message. But if this number exceeds the range of int, then again we will get the error message, and in this case we have to keep it here after this number. So you must be careful when to use this literal in long as well as float and double, and only then everything would work fine.